Okay, in this example for section 6.1, the standard normal distribution, here it says from 1984 to 1985, the mean height of 15 to 18-year-old males from Chile was 172.36 centimeters and a standard deviation of 6.34 centimeters. Let y be equal to the height there of a 15 to 18-year-old male in 1984 to 85. Hence, given that the y is a random variable with those two parameters for the normal distribution. For part A there, about 68% of the y values fall between what two values? And then what are the respective z-scores for those? So they'd be kind of the same concept of that once we get those two numbers. So again, for this, for 68% of the data, we'll go ahead and fill it in down there at the bottom. We'll anchor that mean in the center, so we know that we're at 172.36 centimeters. And then we know that the standard deviation is this a little bit different than the other examples we did, but changing that to 6.34. So let's go ahead and start off with 172.36 plus 6.34. So in this case we get 178.7 plus another 6.34. Next one will be 185.04. So let me go and write those down. Okay, and the last one, let's add another, for that last value, the last 6.34. So plus 6.34 gives us 191.38. Centimeters. Backtracking, going back the other way, let's go ahead and subtract there. Let's take the 172.36 minus the standard deviation, which again is subtracting the minus the that number there, 6.34. So we get 166.02. Let's do that again. We can just go to equals, get 159.68. And then one more time, 153.34. Okay, and all those rounded to 2 places to the right of the decimal. So what we're going to do is answer the following there for part A, part B, and part C. Part A between what two values there. So we can pinpoint that within one standard deviation of the mean. So the lower bound there at 166.02 and the upper 178.70. And of course, what are the respective z-scores? If you're below the mean here, so that would interpret as z is equal to -1. If you're one standard deviation above the mean, z is equal to +1. So those are the respective z-scores for those when talking about 68% of the data within one standard deviation, or that is between or one standard deviation below or one standard deviation above the mean there at those points. Let's keep going there with the next one. For part B, 95% of your data is going to be between, let's slide that over, between those two numbers there, the 159.68 and 185.04. The z-values associated with those would be at -2 and at +2, at +2, indicating that's within 2 standard deviations of the mean there, between -2 and +2. And the last bit there, what is z-scores associated with 99.7%? Just one more time out here. So then the last two numbers there would be between 153.34 and 191.38. Here we know that z is equal to -3 and that z is equal to +3. So that'll do it there for this type of problem application of the empirical rule, looking at 1, 2, or 3 standard deviations within the mean and what those values are.